Hi everyone, this is me Basim and welcome back to my channel. So today in this video we are gonna solving this physics question. This question is from May-June 2024 paper 4.2. So let's read the question carefully. It says that state what is meant by the internal energy of a system. So as you already know, the internal energy has a formula delta U is equals to KE plus PE. So let me write the definition of this internal energy. It is basically the sum of kinetic energy and the potential energy. It is the sum of kinetic energy and potential energy of the molecules. Molecules or particles both are same thing in a random motion. We just write the definition of the internal energy of a system by using this formula. It is basically the sum of kinetic energy and the sum of potential energy of the particles in a random motion. Okay, so let's move to the B part. It says that with reference to the molecular kinetic and potential energy, describe and explain how the internal energy of the system changes when a gas is heated at constant volume so that its temperature increases. Just focus at this part of the question. It says that the temperature increases. And as you already know, there is a direct relation between the kinetic energy and the temperature. How? Because it is basically kinetic energy is directly proportional to the delta T. Now, delta T refer to the change in temperature of the particles. So, when there is a change in the temperature of the molecules or when there is a change in the temperature of the particles, so the kinetic energy of the particles also changes. Basically, there is a direct relation of the kinetic energy with the change in temperature. When the temperature increases, so kinetic energy also increases. As temperature increases, as temperature increases, kinetic energy of particles increases. Now it says that a gas is heated at constant volume. So when there is a constant volume means there is no separation, no change in separation between the particles. And as you already know, potential energy is directly depending upon the separation or the distance between the molecules. So when the distance between the molecules or particles is constant, so the potential energy is also constant. Okay. So we will write this potential energy. Potential energy remains unchanged. Internal energy has the equation as I mentioned you earlier, delta U is equals to KE plus PE. So in this equation, when the potential energy is constant, so the internal energy only depend on the kinetic energy of the molecules. And when the kinetic energy of the molecules increases, so internal energy of the particles or molecules also increases. So we write hence internal energy increases. Now let's move to the second part. Over here, it says a wire is stretched within its elastic limit at constant temperature. So you can see the temperature is constant, and when the temperature is constant, so kinetic energy is also constant. Kinetic energy, kinetic energy is constant because the temperature is constant. As the temperature is constant, so the kinetic energy of the moving particles will be constant as well, because the all the particles will be moving in a will be moving with the same speed. And you can see over here a wire is stretched within its elastic limit. So when something is stretched, basically inside a wire, there will be some particles and there will be a separation between the particles. As the wire is stretched, so the particles inside the wire will be separated as well. So an increase in the separation between the particles. So as the separation between the particle increases, so the potential energy increases. So we'll write this thing, potential energy increases as the separation between the molecules increases. So for this case, where the kinetic energy is constant, so the internal energy only depend on the potential energy of the particles. And when the potential energy of the particle increases, so simultaneously the internal energy of the molecules also increases. Hence, internal energy increases. Increases. So that's all for now. We'll meet in the next video. Till then, take care. Goodbye.